So there's a third important kinematic equation that we didn't talk about yesterday that I want to talk about today. And we're going to see why that these kinematic equations are important. Let me just bust through them real fast. If this is our cart scenario, it's on the ramp. When we start looking at it, it's somewhere in front of the zero. It's already moving to the right, so its velocity is to the right, its acceleration is to the right, and its position is to the right. So this guy is going to start already moving and getting faster. So its velocity is (106). Yes. Class has a target. No, but I'll tell her when she gets here. That's fine. Sorry, phone call. What are you gonna do? So this is the velocity and the acceleration. Since the slope of this is constant positive, the acceleration is constant positive. So I'm feeling okay about this. And from this top one, we can get the equation so this relates the final position, or the position at time t, to the acceleration time, initial velocity, and initial position. And oftentimes we'll subtract the initial position from both sides. The velocity equation is of the form this is the y equals mx plus b that goes with this graph. And then in a previous video, we dropped this down, we shaded the area. And from this area, we got a new equation that's related to this one. The position, the change in position, the displacement, is equal to 1/2 t v plus v0. Now, I like these equations because it's going to help us with some problem-solving aspects. But when you look at all of these, basically we're just dealing with 5 different variables. Okay? We're just dealing with 5 different variables. The variables we're dealing with are the displacement, initial velocity, final velocity, acceleration, and time. And so when you look at them, it gives you a sense of what's what. Now, the thing about this is that if you wanted to use this equation right here, you would have to know 4 out of the 5. But what you'll notice is missing is the displacement, the change in position. If you look at this one, you have the change in position, but you don't have the final velocity. In this one, it's really interesting because you have the positions and the velocities, but you don't have the acceleration woven into this one. And so, depending on what you're given, that dictates your choice as to what you want to use. Okay? So the question is, what happens if we combine some of these? Okay? If we combine some of these, can we get an equation without time? That's the question. Can we get an equation without time? So what we're going to do is we're going to solve this equation for time, and we're going to insert it into this one, and we're going to see if we can't get it to simplify a little bit. Okay? So first, let's solve this equation for time. So I subtracted v0 from both sides, divided by the acceleration, and I got the time. Now what I'm going to do is I'm going to take that and I'm going to substitute that time into here, and let's see if we can't get something interesting. So from here, now we're just doing an algebra problem, which is not a big deal, but let's see if we can't make it happen. First thing I'm going to do is I'm going to multiply both sides by 2a. If I multiply this side by 2a, I can get these to cancel, and I'm left with 2a delta x is equal to that. And when you look at this, this is an expression you know how to work with, right? It's two binomials right here. And what do you do with two binomials? Two binomials. You do the same thing you do to an evil plan. That's right, you FOIL it. And so to do that, you multiply the first two. If you're looking closely, you can tell that those two middle, they're like terms and they're actually opposite, and so they subtract to 0, so you end up with 2a delta x is equal to b squared minus b0 squared. And the way that we normally see it looks like this. And this equation is important. It shows up on the AP equation sheet. And this is the most important one because what you'll notice is this equation right here doesn't have time as any one of its variables. And so oftentimes you'll be given a problem that says, here's your other things that you need to know, but you're not given time. Can you solve 3 out of 4 of those? So this equation is going to be hugely important for us moving forward.